Happy Wednesday, everybody. So for the rest of the year, we're going to be studying, well, for most of the rest of the year, we're going to be studying different methods of integration and then the applications of integration. There are a couple other little topics we'll learn, but this is going to be the main focus. So one of those rules that we're going to study, the rule we're going to study today, is something called integration by substitution. So let's start off with, do you remember the chain rule? Then, of course, I do mean the chain rule of integration. With the chain rule, you take the derivative of a function that is something called a composite function, because it's got one function inside the other. And when you take the derivative of the composite function, remember, you take the derivative of the outside times the derivative of the inside. So this part was your d out. This part was your d in. So that means, of course, we work ourselves backwards. If you are going to take the integral of your derivative, then your answer would be what we had originally. It would be your composite function. And so to do this, we're going to use something called U-Substitution. And with U-Substitution, we're going to set whatever your g of x is equal to, whatever your inside function is equal to, we're going to set it equal to u. And then we're going to take the derivative of u with respect to x, and that will be the same thing as whatever the derivative of our g of x is. So I am going to do a bunch of examples for you to show you how this works. And then for your homework tonight, it's going to be just examples practicing these different methods. So, there we go. It's lagging for some reason. Our first example, let's take the integral of 2x times x squared plus 1 to the 4th power dx. So what you're going to do is you need to figure out what is the inside function, and you won't always pick the right thing, but for most of these I think you will, it will be pretty evident for most of the problems we do today what the inside function is going to be, and that includes with your homework, not just with my examples. So kind of just off here to the side, I look for some set of parentheses, and that is going to typically be your u. So in this case, x squared plus 1 will be my u, which means du dx will be 2x. Now we're going to do a trick here that we've never done before. It is actually, well, okay, it's not actually a legal move. If you talk to real mathematicians, they'll get mad at you for the way I'm about to describe this, but then even they will admit it works. It is a legal move to do that. And what I like about that is that shows up in my problem right there. So what this means here is my du will be 2x times dx. So what I can do is I can take out the 2x dx and replace it with a du. That's, again, this is called integration by substitution. And I can take out my x squared plus 1 and call that u to the 4th power. And look at how much easier this is. This is one of the first integrals we taught you. That's just going to be, you take u to the 5th, you add 1 to the power, and then of course don't forget to take 1 over that number out in front as a coefficient. And because it's an indefinite integral, don't forget your plus c. And you're not done yet, but the last step is super simple. All you need to do is plug back in what u equals. Plug back in your system with your x's. And that's it. So this is going to take some examples to get used to, but I think that you're going to get used to it pretty fast. Now, of course, I'm going to do a bunch of different types of examples. The ones towards the end of the lesson will be the ones that are going to be the most different. The ones that, if you get bored with some of these examples as I go through, don't skip the ones at the end. Just putting that out as a warning in case anybody does decide to skip to the end at any point during these examples. Okay, so another example here. Again, pick what's inside the parentheses to be your u. So here u, I'm going to pick that to be x to the third plus 1. If, by the way, you pick the wrong thing to be u, just go back and pick your other thing and see if it works. Like I said, you're going to make mistakes here and there, and that's okay. Just try again. So we pick our u, and I'm going to take the derivative of u with respect to x. And when I do that, I get 3x squared I'm getting ahead of myself. I get 3x squared. And I can do that trick where I can multiply both sides by dx. And I end up with du equals 3x squared dx. Now, on this one, I can see I've got part of that, but I don't have the 3. Super easy to manage. If it's a constant, if it's anything but x, really, you are allowed to move that 3 over, just like we moved the dx over. So that means that if I have x squared dx, it'll be the same thing as 1/3 du. So what I'm going to do here is I've got my integral, and let's go ahead and plug in what my u equals. So this will be the square root of u, and then times 1/3 du. And then let's clean it up a little bit. I'm going to put the 1/3 out in front because it is a legal move to pull that out of the integral. I'm going to change the u to its power form because integrals and derivatives are always easier in power form. And as I take the integral, I'm going to add 1 to the power and then multiply out in front by the reciprocal of that power. And then, of course, put in a plus c. And if you get excited and think you're done, this is probably the most likely mistake you're going to make here, is you're going to get this far and then say, I'm done, nothing else to do. But truth be told, you're not done yet. First of all, I am going to go ahead and distribute these. That's not what I'm talking about, though, when I say you're not done. When I say you're not done, the big thing is you have to put your x's back in. The problem does not want u's as your answer. It wants the function in terms of x. So always make sure you substitute back in whatever your u was equal to. All right, let's see. Let's try something with trig. I know trig is one that we're going to need to probably practice a little bit more. So let's do this problem right here. So here, this is the sort of example where it might be tempting to choose secant squared equals u, or it might be tempting to do tangent x plus 3. These sort of problems are the ones you're, I would say, probably most likely to choose the wrong thing on, especially if I didn't have the plus 3. The plus 3 does kind of give it away. But again, if you pick the wrong thing, if what you pick doesn't work, just pick the other thing. No harm, no foul. So I'm going to pick the tangent of x plus 3. And I hope that you remember, you will need to have this memorized for the AP test. The derivative of a tangent is a secant squared. And then, of course, the derivative of 3 is 0. Again, that's why I said the 3 kind of gives it away. Because that part, there's no way to take secant squared and have its derivative have that 3 inside of it. All right, so we're going to do that trick again, where we're going to multiply both sides by dx. And when I do, I get du is going to be the same thing as secant squared x dx. And it's always a good idea to go back and just verify, is that in the problem exactly? Because if it's not in there exactly, you're not done with that part of the problem yet, with the substitution. Okay, so we have u, and then on this part right here we have du, about as simple an integral as you possibly could get. And of course you're not done until you substitute back in what u equals. And if I'm going kind of fast, first of all, two things. Number one, you're watching a video. Slow the video down. Pause it if you need to. Go back and check that front flap of your book where it has all the lists of integrals and derivatives. Verify the things like verify that the derivative of tangent is secant squared. Number two, the more of these you do, the faster you'll get. So that's why I'm going to go through several examples today. And I also, in your homework, I'm giving you lots of, it's not necessarily a difficult homework, but I am giving you lots of problems just to go through and practice this process. Okay, what do I have next? Oh, this is another good one with trig. Pretty simple. But if you look in your book, and by the way, if you look in the flap of your book, where it has all the derivatives, that first flap, you do notice that it actually has your derivatives listed in terms of u. That was not a mistake. That actually has to do exactly with what we're teaching you right now. On this one, it seems like you maybe, I know some people look at this and they think that they don't need a U-substitution, but you never were taught the integral of cosine of 5x. You were only taught the integral of x, or rather the derivative of cosine of x. Sorry. So we do want that 5x to be our u, because when we integrate, we don't have a rule for that. So we take the derivative of u with respect to x. We get just 5 out of that. Multiply both sides by dx. And we get du is equal to 5 dx. Now that 5 does not occur anywhere out here. So we are going to need to move the 5 over on the du side, because it's not something we can pull out of the problem. It's actually something we need to put into the problem. So we're going to have the cosine of u times 1/5 du. And I'm going to move that 1/5 again outside the integral. And the integral of a cosine, you have to think about what function, when you take its derivative, gives you cosine. And if you take the derivative of a sine, it gives you a cosine. And then last but not least, we plug in what u equals. Now on this one, some of you maybe have noticed that I'm keeping this plus c on the outside. Like for example, I have this 1/5 here. I know some people might be upset by that, and they might prefer that I put the parentheses here. Truthfully, it doesn't really matter. I think it's a better idea to put it where I originally had it, but if you were to distribute 1/5 through this problem, wouldn't you agree with me that 1/5 times a constant just equals another constant? So that's why I personally will leave the c always on the outside of my parentheses, just because no matter what I multiply it by, it's just another constant. If I'm multiplying it by a constant to begin with, I should clarify that. If I'm multiplying it by something with x, obviously it's not a constant anymore. Alright. Now this next one, this one's kind of a fun one. It's another one with trig. Which, I mean, that's part of what makes it fun. It's not the only thing that makes it fun. Now this one's kind of complicated. There's a lot of stuff in it. So we see that we have a 3 inside of our trig functions. 3x there. So that obviously is going to play a part. And I know that with sines and cosines, if I take the derivative of one, I get the other one. This one maybe is going to be one you're a little more likely, perhaps, to make a mistake on. I can tell you, for me, that squared is what gives it away. I want my u to equal the sine of x, because my du dx equals cosine of x. Oh, and let's go ahead and put the 3. I do actually want it to be cosine of 3x. And then my derivative will be cosine of 3x, so the derivative of the outside, times the derivative of the inside. And then I'm going to do that trick where I multiply both sides by dx. That's called using the differential. So I get du is equal to 3 cosine 3x dx. I can see part of that, but I don't have that coefficient of 3 anywhere. So I will need to move that piece to the other side. And my integral now will look like u squared times 1/3 du, which will need a little bit of rearranging. Well, I guess it doesn't absolutely need it, but I personally think it's easier to handle if you rearrange it. Add 1 to the power, multiply by the reciprocal, do a plus c, and do not forget to plug back in what u is equal to. By the way, fun fact, now of course I had the squared there, but let's pretend that that squared didn't exist and it was just sine of 3x times cosine of 3x. You actually, if this was the case, you could use u equals sine of 3x or u equals the cosine of 3x. It's one of the rare cases where it doesn't matter which thing you pick to be u, they actually both would work for the problem. Your answers would look different, but the answers would be equivalent to each other. So just a fun fact there. Alright, as I was going through and making this lesson, I titled it for myself, Death by Examples. And I'm sure that's what it maybe, it doesn't feel like that yet, it probably might. But this is all just going to be pattern recognition. For some people that came to parent-teacher conferences, I kind of equated it to verifying trig identities. The math itself is not anything like doing verifying trig identities, but both of them require you to problem solve, to look through the problem and to piece your way together. And it's not quite like algebraic manipulation where it's all just about moving stuff. Although that does get involved too. Alright, on this one, it is always a good rule of thumb. Now, of course, the parentheses on the bottom kind of give it away what I want. But in general, it actually is a good rule of thumb to pick what's in the denominator to be your u in most problems instead of your numerator. This one's a little more obvious, especially since the derivative of u with respect to x is negative 4x. And I have part of that already in the problem. So, only thing I don't have, notice, is that negative sign. So I'm going to need to multiply or divide by negative 1. Either one will work, because with ones it does not matter. So I now am going to have 1, or rather negative 1. I'm going to go ahead and put that negative 1 from the du on top, over u squared du, which will look like, let's go ahead and pull that negative out here, u to the negative 2 du, add 1 to the power, multiply by the reciprocal, but in this case, because it's 1, same thing as doing this, and add c out in front. And then you just need to simplify. Negative times a negative becomes a positive. U to the negative 1 is the same thing as 1 over u. And we need to, of course, plug back in what our function was equal to. In other words, we need to plug it in so it's got its x's in it. Alright, I have 2 more examples, and this is where it's going to start to feel a little different. These are the ones where when I said don't skip ahead or just ignore the examples and think that, oh, I've got this, because you're going to run into some situations like this. Now, again, this one, pretty obvious what I want to choose u to be. Use the thing inside the parentheses if you have anything with parentheses. And square root is just a special form of a parenthesis that does something special. So I go through my process. My du dx is going to be equal to -1, multiply both sides by dx. I get du is equal to -dx. And I've got that, and I can put the negative in. That's no problem. But the problem is I'm still going to be left with an x. If I go through and start substituting this in, well, let's actually, first of all, let's move that negative over. I'm going to have negative. I'm still going to have this x here, and I'm going to have the square root. I'm going to go ahead and substitute in what that equals. And substitute in, I already did the negative. Let's finish it off with the du. And here's where you're going to run into problems. You cannot integrate a problem that has both x's and u's in it. Not possible. No way to do it. You do need to keep manipulating this so that all of the x's go away. Very conveniently, we have a fact that equates x's with u's. We just need to manipulate it. So, remember I told you u is equal to 1 minus x? Let's play with that. Let's add x's to both sides. And let's subtract u from both sides. So, on this side my u's cancel. On this side my x's cancel. And I get x is the same thing as 1 minus u. I'm going to substitute that fact in as well, because these problems are not possible to solve until your x's have all disappeared. That's as hard as these problems are going to get, by the way, for today's homework. I do need to clarify that. Now, let's play with it before we take the integral. So I have 1 minus u. I'm going to change that to its power form. Square roots and 1/2 are the same power. And then I'm going to distribute, because this is a lot easier to handle. In fact, you don't have a method to solve for this while it's being multiplied together. You have to distribute. And we add 1 to the power, multiply by the reciprocal. We add 1 to the power, multiply by the reciprocal. And don't forget your plus c on the outside. When you take your basic skills test, which you are going to do next week, basic skills for integrals, I will not count you right if you forget your plus c on a definite or an indefinite integral. One step left to go. Let's see, I'm going to go ahead and distribute that negative through. And I'm going to plug in u is the same thing as 1 minus x. And you could do algebra and change the way this answer looks, but I think it's just fine to leave it the way I have it here. I think it's just a little bit easier to leave it at that place. Okay, I have one more example, but it looks like I'm going to need a shift on my screen because I'm running out of room there. There we go. Okay, last example of the day. This is just going to be another example similar to what we did in the last problem. So u is the thing inside parentheses, if you have a set of parentheses. I'm going to take the derivative with respect to, derivative of the equation u with respect to x. By the way, you know, let me sidetrack here for a second. This whole du dx shouldn't be that strange, because if I had it in terms of y's, remember one way to write the derivative was derivative of y with respect to x. Okay? Just want to bring that up. I'm taking the derivative of the u function, the function of u, with respect to the x, and so that's where that du dx is coming from. That's what the notation means. All right. I use the differential form to find du is equal to -2 dx. I don't have the -2 anywhere in this problem. Not on the outside anyway. So I am going to need to move the constant over. And remember, it's really only constants you can do this with. So it looks like all I'll be able to pull out here is the dx. So I have this piece here, and I have this piece here. I'm still going to have that x left over. I'm going to use the same trick we did last time. But let's show you what we've got so far. So I'm going to use my u function to solve for x. And I get x is going to be the same thing as 1 minus u over 2. Worst thing about this is it's got a fraction inside a fraction times a fraction. We're going to have to clean it up. Not only I recommend that you clean it up before you take the integral, you kind of have to clean it up before you take the integral. Not that hard to clean up, though. First of all, the constant, I'm going to bring it out in front. Can't bring out anything with a u, or that has a u attached to it, but if it's just a coefficient, it can come out in front. That's okay. Next, you need to think about my little sister. And for the students who are new, the other students have heard this before. Anytime you are going to have a fraction divided by a fraction. And by the way, if one of them doesn't look like a fraction, give it some legs. It has its head, give it some legs. So one thing that people have heard over and over and over and over again is, ever since my little sister was about 2 years old, I love to hang her upside down. I am the oldest. My head stays where my head stays. My feet stay where my feet normally stay. But my sister, who's the second, her head and her feet are going to switch places as we change this into a multiplication problem. So looks something like this. And I'm not done yet. Like I said, it's got some cleanup to do. You're going to multiply straight across. So the top stays the same, and on the bottom we get this. Which, let's go ahead at this point and change that square root to its 1/2 power. Same thing, just a different way of writing it. Now what I'm going to do next is I'm going to give each thing its own fraction. Because I'll be able to simplify it in a way that'll be useful with my rules, because right now I still can't solve it with the rules I've learned so far. So, on this one, I have 1/2, and then because my u is on the bottom, I can write that as u to the -1/2. Bring it upstairs if I make it a negative power. On this next piece, I have this 1/2 that I'm going to pull that out, and then I've got u times u to the -1/2 power. I'm going to have to clean that one up a little bit, but we have a rule that says when you're multiplying together to any things, really, it's not just variables, that are the same base, then you're going to add together the exponents. So 1 plus negative 1/2 gives me positive 1/2. So that comes from the rule, like if you have a squared times a to the third, that's a times a times a times a times a, which is the same thing as a to the fifth. It is a legal move to add together your exponents to find what that will equal. Alright, now I've got everything in power form. It's fantastic. I'm going to go ahead and pull out that 1/2 because I've got it in both. I'm going to factor that out and I get negative 1/4 u to the negative half minus u to the positive half. And that's as simple as you'll be able to get your integral. Now we can take the integral. All of that was just algebra just to get ready to take the integral. So let's see. Add 1 to the power, multiply by the reciprocal out in front. Add 1 to the power, multiply by the reciprocal out in front. And because it's an indefinite integral, include your plus c. Let's see. I have to go back. U was the same thing as 1 minus 2x. Oh, not U. 1 minus 2x to the 3/2 plus c. And personally, I would clean this up by distributing that negative 1/4 in now. So 1/4 times 2, or negative 1/4 times 2 is negative 1/2. And negative 1/4 times 2/3, you've got a 2 on top, a 4 on bottom. Those are going to, well, a 2 will cancel out. You'll still be left with 2 on the bottom. 2 times 3 is 6. Your 2 on the top canceled, and you have a negative times a negative, so that will become a positive right here. And that's going to be as clean as we're going to worry about right now. Okay, so again, best thing you can do is just practice a bunch of these. Use the opportunity to go through. Let me stress to you, these are going to be some of the easier integrals we're going to learn in the upcoming months. If you get stuck, please contact me. Even though I don't have office hours on Friday because we're following the Granite calendar and because of parent-teacher conferences this week, there is no school on Friday, which doesn't really impact your usual Fridays for this year, but it does for the teachers because we're not holding our office hours. Anyway, if you get stuck, please contact me. I will check my email, not much this weekend, but I'll check it a couple times. And I'll help you through. You have the long weekend if you need it to finish the assignment, but try to finish it before Monday. My goal, I would like to see how many of you can get it finished by Friday night. Just because, again, so much of the year is going to depend on these skills. And we are about ready to take your next and last basic skills exam. So like I said, we're going to do that next week, and these sort of problems will be on that exam. Which, one more time, for those of you that had me last term and have already taken a basic skills test with me, and for those of you who are new, then this is something that you haven't done yet. The good news about the basic skills exam is everybody is guaranteed an A. The bad news of it is you're going to retake the test until you get an a different version of the test every time. So you guys haven't broken my record yet, but before this year, I think my record for one basic skills test was like something like 7 or 9 times on one test. And again, different versions of the test. But taking it over and over again until they get it. Actually, it might have even been double digits. It might have been like 11 times or something. Anyway, so do these homework problems. Get ready for that basic skills test. in class next week, I think, let's see, on Tuesday next week, we'll go through and give you the problems for your basic skills test to start practicing. And if you get stuck again, let me know. I want here to help you.